Hello, hello. How's it going, everybody? Starting a little bit late here. I swear, I'm not having good luck with things working from the get-go. I started up OBS and Elgato capture card was not working. So then I restarted, and then audio stuff wasn't working. Computers, let me tell you. Okay, let me tweak this audio here. I would actually like it a little bit louder from me, and then I think we can go down a bit. I think that's probably good for y'all. Yeah. We'll give that a shot. Okay, so. And I just saw the bot send a message. Is that not working now either? Should be. Should be. Unless all the changes... No, they're there. I think we're working. If I do a message, this should hopefully check if we get... I think I've got check commands showing up there still. What broke? This is ridiculous. I swear, I fix it off stream and then it works, and then I go to stream and just like nothing is working. Oh my goodness. It is not pending at all. Okay, here let's just go over. Y'all can. I think I did this last time too. I mean, at least my audio is coming through and it's not. I should actually. Got it muted, right? Yes. Okay. Well, something's right at least. Nothing. It's just like decided to stop. I would love if something just worked. Yeah, okay, it just says it's auto connecting. Connecting. Why are you still connecting? Alright, let's close StreamerBot. We'll open it. I don't... Why do I have to sign in again? I don't. It shouldn't open up in this tab, but I'm gonna just move it over just in case. Oh, okay. All right. Let's just do this for a second. I'm not sure where it's all gonna open up. Sign in. Now it's connected. Okay. So despite it saying connected, it was not actually connected. I think we can go back to this. This. Now we should be able to. Let's just restart the chat thing just to be sure. I went through the effort to do this already. That's what I'm expecting to see. And actually it's should have it behind the camera. or in front of the camera rather. There we go. So now we should be able to see this come through. There we go. Oh my goodness. Okay. Breathe. I would love if things just worked on the get-go, but I don't think Elgato, the Elgato capture card has it ever worked? I seem to always have to restart. Like it's just like loses. I don't know. It just like goes not responding, and I stream once a week, and I guess that's enough of a time frame that just at some point goes not responding, and depending on when I restarted last, I get lucky. I think maybe I just need to, like it might be a sleep state thing. Maybe I just need to restart the moment I sit down in the morning, so I don't have to deal with this. Because this is a pain every time. Anyways, let's actually get into what we were sitting down to do here. Today we are, I might as well just drop it in here since I haven't actually gotten around to doing like a project thing. Today we are, I guess it's in the description. Do y'all read the description? Is it worthwhile to just depend on having the description note what the project is today? Yeah, let's do that. See the description. We are again working with WGPU, and we've kind of got everything set up, and we see something in Chrome. So WGPU is generating and in dev creating a dev server to host a WASM file and an index.html that loads the WASM file. That WASM file then using I believe we got it working last time, the WebGPU API, which is a newer spec for 3D graphic type things in the browser. I don't think it's specifically 3D. I think you can do 2D as well, but it's the only thing that really, well, I was gonna say it's the only thing that does 3D, but the previous spec, WebGL, which isn't necessarily going away, that also does 3D. But this is one of the primary APIs and the newer API to do 3D things in the browser. So it's the WASM file is running code which uses the WebGPU API to draw things on the screen. And we're going to take that code that we have running from an example and try to strip out a bunch of it now, because I think we have everything set up and working as like a separate thing. That was a little bit more work than I was anticipating, but I think we can strip it down now to just the core of what we care about there, and pull in a new shader and see if we can get that to draw. So that's sort of the goal for today. What did I actually even name this? Yeah, what does the shader have to do with WGPU? So WGPU can use a shader as a way, as like an input into the program to do the actual graphics calculations and then handle the rendering then. So shader in, rendered thing out through WGPU. And you might have heard of the term shader if you've in the video game ecosystem. Same concept. I think they pretty much use the same thing, not necessarily the specific shader language, But we're starting to get into that territory where we get crossover into the video game ecosystem. So let's spin that up. Let's see if I actually remember where I put it. I think I put it in stream overlay. Pretty certain. I'm not sure why I know it times out the first time I go into a directory every time. I feel like it's one of those things that like is broken and kind of annoying, but like actually doesn't really affect anything, so I just haven't to actually adjust it. Oh my goodness. Fine. Go ahead and restart. Luckily, a new computer does that a lot faster than it has in the past. So what we were working through was the main RS. I'm gonna make it just a little bit smaller here so I can read it a little bit better. We don't need this all the way open. And we have everything running, and it's running this example, which we could probably strip some of this out because it's not technically an example now. They just have it in example struct. So like this is, I mean, it'll continue to work, and it's looping through the framework example, which comes from framework. And we really only have one. Some of this, like, I'm not sure why it's... I wonder if that's flow history. But I don't know why it's like... It's not graying it out. It's... decontrasting it? Desaturating, maybe that's a better way to say it. Or is it saturation? My color theory, color background is not great. I don't know all the terms there, but I'm not sure. So we should only have pretty much one target at this point. So that was a bunch of what we were doing the other day, was stripping out the pieces to actually do DirectX, because we don't care about that at the moment. This framework RS was set up in a way that it could handle anything that the WebGPU thing could render. So it has down level capabilities, which means in our case that if you're doing WebGPU or WebGL, the APIs to do WebGL do not match the newer WebGPU APIs. So if we're using something that WebGPU is set up to handle that only works on WebGPU, we're gonna see an error. Otherwise, what it's gonna do is it's gonna take that code and then basically produce it for WebGL instead. So this down level thing here is like a way to handle that situation. So I think we're actually getting rain here. I've been hoping for rain for a while. Okay, so we want to strip out some of this code here, I think. And we want to focus on we've got a render pass, resize. I mean, we can leave resize and update. Those are fine and they're relatively small, so I'm not gonna worry too much about them. And then we have an init. And that's the bulk of the code here. A run, and then we have an init and a render. The init, is there anything that we're going to need to do in there? So last time we started getting into the shader language, or into the terminology around the shaders. There's draw shaders and compute shaders. Chris was very helpful and kind of mentioned the difference in the previous stream. I'm definitely going to have to go look that up because I do not remember offhand what the difference was. I think we might just need the draw, but the compute, I believe, is just to handle math, and then draw shader is the thing that actually does the render. So init is taking these shaders, which we will look at in a little bit, and it is creating this bind group layout. And you can see here, this is doing, or these entries are all compute entries. And then it creates a pipeline. So we have a render pipeline and we have a compute pipeline. I'm not quite sure why it creates an empty or a render pipeline with empty bind group layout. I would appreciate a comment that actually says why would be much more helpful here. This was copied from the example. I mean, I can kind of see that that's what's happening. So why would be very helpful there. And then a render pipeline. So we have a compute pipeline layout and a compute bind group layout. One passes into the other. And here we have a render pipeline layout and then a render pipeline. Which seem to be bind group. Similar-ish, but not quite. And I think part of that difference is the device.create render pipeline. And then we've got a create a bind group layout. So there's a bind group and then there's a render pipeline. But what's interesting is we do have a compute pipe layout and a render pipe layout. So TBD on what those do. I mean, we know that there's a difference. We know that the APIs we're expecting the APIs to be slightly different because they have different functions. Not just as like programming term functions, but like they do different things. But I think that's about the amount that at least I personally am getting out of just reading that code. The create compute pipeline. So now here they're actually making a compute pipeline, which I feel like they could have done up here. Because I don't think any of this stuff depends on that. Should I just move it up? We're gonna move it up. I don't know if it actually matters or not. I wouldn't expect that the order of stuff matters terribly here because all of the places where we can do parallel compute, I believe it's handing it in a way that'll do parallel. So here we can see bind group layout, then we create a pipeline layout, and then the pipeline. And here we do a layout and then the pipeline. So the difference from what I can tell is the render pipeline does not actually start with a bind group first. The bind group, I presume, has something to do with the fact that we have 3 entries. And binding 1 or 0, 1, 2, visibility. What's TY stand for? The type of the binding. So we have a buffer, and a buffer. And then this one is a uniform. So this might actually be like the background. Not certain, but potentially. And then here, number of particles. I think we do actually have 2 layers in our existing shader, and then there's a black background. Possible. We'll keep that in mind. So create a compute pipeline, and then render pipeline. And now we set up a bunch of buffers. With particles. I'm not sure exactly what is considered a particle. And then they create bind groups for each buffer. And then we effectively return. And that is the initialization. So in the actual render, we call render on each frame, and we dispatch compute groups proportionally. Triangle is draw call for all number of particles at 3 vertices each. I vaguely understand that. So every frame they call render once. This part I don't quite grasp. Like, I understand the words, but I don't understand the significance of them. So color, I'm not sure what the descriptor is. It looks like a label, maybe? Command encoder. And then we got some debug things here. And we have a compute pass. Which references the compute pipeline. And we have our particle bind groups. And then we have a render pass. So we do a compute and then a render. And I think what we could probably do is, this is being called on every frame. If we would remove one of these passes, like the compute pass, we can see it if we get an error and if we actually see any change. And I think that might be helpful as far as like the next step. So let's get this running. And we can see what we have so far, what it looks like. We did in the previous stream. What's that command again? Terminal history, save. So this is what we got. I'm gonna zoom out just a little bit here. Kind of a lot going on. If we now go into here and oh, not the framework. If we take out a compute pass, I'm not sure if it's going to actually error or not. But let's see what happens. Could not find file. Okay. It doesn't seem to have restarted the server in any way, which feels odd. I thought I like watched it. Okay. So those were never read. Okay. Compute. Compute pass determines the movements. So the render pass is actually showing the entities, the triangles that we're rendering. And that actually comes back to here. We dispatch a compute group proportional. I'm not sure what the proportional means. Maybe proportional to the number of particles. I believe they're referring to each one of these things as a particle. So like one of these would be a particle. And from there, we're doing a triangle list draw call for all number of particles at 3 vertices each. So each triangle has 3 vertices or 3 corners. So the compute pass is determining the position, and then the render pass is actually rendering it. I'm guessing we can also render words. Comment to that out. And it appears we do need to rerun this every time, which is a little bit annoying, but I thought we could watch or do like a watch. So no render pass. We don't get any values in there or any particles in there. So as far as the rendering a frame, we sort of have a good understanding, I think, of the difference between each one of these. And if we would look at the draw and the call, the draw and the compute, the compute is the thing handling the position. The draw is actually doing the render. So it's returning a vec4, which is I think the compute is considering each particle like a point in space, and then this is the information here required to actually draw the triangle. Position X. Yeah, so sine cosine of the angle, where angle is part of the particle velocity. So depending on the velocity of the particle, it's going to be in any rotation. So we know that the velocity of a particle is this way. If it's going this way, we can draw a triangle based off of that like velocity line. So we know what angle that thing is facing, and then around that we can draw a triangle. Should we do it here? So if the velocity is going straight up as far as we're concerned, we can draw a triangle around that. So this is specifically just drawing the actual triangle, and then as far as the location of that particle itself, that's what's happening in the compute. So we see a bunch of position, velocity, mass would determine, I'm guessing, I don't think there's any, oh, there's a little bit of collision. So the mass, presuming it would be different between particles, will affect how they recompute when they run into each other. So we do some stuff with the distance to check if they're colliding, I'm presuming. Clamp velocity for a more pleasing simulation. So it can only go so fast. And then wrap around. So if a particle goes off, it comes back around. And then right back. So I think we kind of understand what's going on there. And if we take a look back at this again, did we? Yes, we uncommented that out. We get a refresh. So you can see that some of these particles are like running into each other, and they kind of move around a little bit relative to, they like group up. So they move in a way that they run into other entities or particles, and then shift around, and then eventually they seem to group up. Hey Ben, good to see you. Disclaimer, I did not actually make this. We're breaking it down and ripping it out and trying eventually our own thing. So with what we have here within this render pass, for each render, for every frame that's rendered, we get a compute pass and then the render pass. And those are using the pipelines that we have previously set up. So if we go into here, let's shrink some of this so it's easier to see it all. So you have a render pipeline and then a compute bind group layout into a compute pipeline layout and then a compute pipeline. So these two things are what's controlling the compute pass and the render pass. And they are set up based off of the shaders and some initial buffers. So I'm assuming if we play around with these simulation parameter data, we'd be able to see these are kind of like the input. So we don't have any like sliders or anything in our UI, but those are going to act like our sliders. So within each shader file, can we get a WGSL? Is there a syntax highlighter? Yeah. $19,000? That seems reasonable. That seems reasonable. All right, so there we go. That looks much more satisfying. So within our compute, the compute is the thing, remember, that's doing the position. So we get sim parameters. So these sim parameters here are matching up with this vec of F32. Delta T, rule distance, rule scale. So if we look at maybe the delta has to do with the kinematic update. Distance. So I guess this determines like if distance is less than rule 1. Oh, it's adjusting the mass based on the distance? Interesting. And then scale is just a scaling factor of the velocity. So mass, velocity, it would be nice if I knew like what the intention of these were. They do have a reference here. Project 6 Vulkan flocking. Shader compute particles. So I'm guessing what they did is they grabbed it from here, and this is a dot comp, which I vaguely recall what it is. What is a .comp? Oh, nice. They did it for a CIS 565. So this might make it a little bit more obvious. That file is strictly just thinking of everything as a particle. The draw call, based on the velocity, is determining the actual triangle. So the idea here is that they like slowly flock together. So I'm guessing that if we play around with like the distance rule, that's going to determine like the packing. How tightly are they going to pack? So we can give that a try real quick here. Whoop. And then I think we probably got a pretty good handle on how it's building everything up. And we can start looking at pulling in a different shader and see how we can do with that. So the distance is a combination of mass, whatever COL velocity is, and C velocity. I'm not sure what the difference is, other than it ends up becoming a V velocity, whatever that. I mean, clearly V velocity is a velocity, but why V? C and V? We have some bindings, particle. Yeah, I'm not sure what's the significance of V versus C and COL. And it does do some clamping, I think. Yeah, velocity clamping, so it can only go... This is going to be the range, it seems. 0 to 0.1 is going to be our... no, what's normalized do? No, normalized I bet you is... when you're doing velocity, you can do positive and negative, depending on how you want to represent it. I'm presuming that normalize is going to basically take the minus off of it if it's a negative velocity. And then the delta. So let's, ooh, the delta is an interesting number. So our rule distance, if we bump this up a little bit, let's go to 0.2. That, I'm guessing what it's going to do is see how they're really starting to pack together. By bumping that up, I think it's going to separate these pieces out a little bit more, and they will still be grouped, but not as tightly packed. Oh. Interesting. And you can see the that loop background. There was some code for where was it in the compute? Keep doing that. In the compute, there's this wrap around the boundary, so you can see that when it's very obvious here because there's much less going on. When it hits a boundary, you can see this big blob here is going up and down. Every time it hits that boundary, it redraws from the bottom. So we have our inputs, and then it sets up buffers to handle most of this. And then I think that the terms that are helpful to pay attention to is based on the device, which comes from the where is that coming from? It's coming in as into the init. So WGPU device that has a method to create bind group layouts and pipeline layouts and pipelines. And this all starts to get into like rendering. If you have worked with like GStreamer or what's the other one? That CLI where you can like edit video files and turn them into GIF or trim video files. I'm completely blanking on it. GStreamer is it newer? Different? It's definitely different. That tends to work with pipelines. Yes. Thank you, Simon. FFmpeg. Does that actually work off of pipelines? Maybe this one doesn't work off of pipelines. I haven't actually looked into the code enough for this one, but I have a little bit looked into GStreamer and documentation. I'm expecting to see tutorials. Pipelines, dynamic pipelines. So as far as I understand pipelines, you have like multiple transformation steps. So each pipeline is like a chunk of code. It's handling the input, returning output, and passing it on to the the next thing in the pipeline. All right, so I think I got a pretty good handle on this. Does anybody have any questions about this? Is there anything else that we need to dig into before we start trying to rip pieces of it out and swap into a different shader? I think so. We pulled this. I believe we pulled this up last time. So we have here. We have a texture on this background here, just to give the digging into the WGPU sort of an end goal or a place that we're trying to move towards, or a little bit of focus on the project. The idea here is that I want to create a browser source in OBS, which is basically just I think for the most part we can just run like a index.html to do a background, and I want to swap this background out for something that's done with WGPU, hopefully WebGPU. I can't remember. I don't think the embedded browser in OBS supports it yet, so we could deal with that later. But basically make a background with shaders that is using a voronoi instead of this like hexagon dealio. And it's a relatively established formula to do those. Relatively, I think there's different ways you can do it, and you'll see here a bunch of comments when you look at these that people say mathematically correct. So as I understand, voronoi are relatively well established mathematically. Maybe that's the best way to say it. So this is written in GLSL, which is like the WebGL, I believe, shader language. We are currently writing in WGSL, so slightly different shader language. But I'm presuming that much of it is probably going to carry over. I think that, or maybe it's better said as I'm making an assumption that what is in the WebGL spec is probably very similar to what's in the WebGPU spec, but more. So I'm thinking we could potentially copy this and just see what it does. There are two sections here, plus this hash. I don't know what the texture versus procedural white noise is. Oh. Seems the same to me. But I think what we got here is this is effectively the same as our compute, and then this would be our draw, I believe. And before we immediately jump to that, the one thing that I want to do, that I want to check on that we mentioned as we started looking at this again, there's these, we have right now we have a compute and a draw shader. They have like different functions, and then they also have these directives, I believe they're called. So you can see here, compute, this is marking this as a compute, and this is actually called main, which leads me to believe that this can probably be copied in there. And then we have a draw, and that draw has an at vertex. So maybe we don't need a draw. But having all that be said, let's go back to the WGPU site and I thought they had a tutorial. So this is going to give us the on docs.rs. This is going to be, I'm presuming it's going to be more of a like API type definitions. So like we could look at this and like if we look at, you know, here's a bind group layout. We were talking about this a little bit. It can be created with device create bind group layout. So it's going to have a little bit of text on like what each one of these things are, which could be helpful. But like, I don't know what a binding group is. I mean, I understand those words as disparate pieces because English, but in the context of WGPU, couldn't tell you. So, all right, I thought maybe it's on the maybe it's on GitHub. I could have sworn. Have you if you're still around, Simon, are you have you been digging into WGPU at all? I know we've been looking at something with that in regards to Linux. Simon is in the Tari working group, I think we're still calling it. We're in the middle of updating governance and whatnot, and Simon's pretty involved. I think Simon has a YouTube channel too, don't you? Nice. Okay. I mean, I started looking into this because I've always been interested in the sort of cross between shader, WGPU, you know, previous iterations of stuff, and like how we could potentially integrate that into Tori. So that was why I started digging into it, but it sounds like it actually might be useful in Linux world, which I am happy that I'm not the one dealing with that, because it sounds like a big sigh. We'll say it that way. Big sigh. Yeah, feel free to drop your a link to it or whatever. I don't know if people can click your name in the chat there, but I guess wherever you have the chat. feel free to give it a drop. So where were we? Tutorial. They don't really have anything, which is why we kind of went down the path I think that we did. There is a wiki that doesn't have much getting started. Okay. So like their documentation are run the examples is sort of the vibes that I'm getting, which honestly, this tends to be a bit of a lower level library. I don't think anybody's like, it's less likely that somebody's using this directly and more likely that somebody's using something that sits on top of it. Like one way that we sort of worked ourselves into digging into WGPU is the eGUI library uses it. I think Bevy uses it offhand as well. And so all the niceties and the removal boilerplate and like the I want to make a game or I want to make a draw a thing is sort of like abstracted out. So you can think about that, and then it eventually does hit the code in WGPU, but this is all the lower level like thing that's actually doing the drawing. So we had pulled out this one, which you know, not a great amount of documentation here, and for the most part it's just here's how you run it. So I don't think there's really too much that we're going to be able to like pull out of this as far as tutorials go, but there was a tutorial. Do I still have it up? Yeah. Okay. Is this the homepage? Yep. I believe Chris Piscardi, who has definitely dug into this more than I have, but he had stopped by the stream last week. We talk about a bunch, and he did a bunch of videos going through this tutorial. I can go ahead and drop this in the chat. It is actually reasonably updated. So I mean, I think last time I looked at it, it was like March maybe that they updated it. Oh no, my chat is covering me up. That's why I did that. Yeah, I guess we'll go with that. I did give a after you drop your link in chat, Simon, if you do !drop, those are all of the Blender models to GLTF to React 3 Fiber to Scene that let's hope it works now. Oh, that would be unfortunate if it didn't work. I literally tried it at the beginning of the stream and it worked. Do I? Oh, did I? Okay. Slight distraction. Slight distraction. It's not like this hasn't happened before. The distractions, but also stuff breaking. Drop. Available to grant type deny only. Allow all. I had set up where only certain people could do it. Give it a try now. I think it's just allow all right now. I also need to like reset up all these commands. I think those are all still set up for Twitch. There we go. That's supposed to fall in front of me. Messages are supposed to be behind me as I hit myself. Everything's an ongoing project, right? Okay, so I closed that. So anyways, Chris went through this on stream, or no, he did a Let's Code 10 months ago, and I think for the most part he went through the bulk of these. So you can see some of these, like here's a pipeline, vertex fragment. Here's the vertices. There's WGSL, and then there's also, do they mention any others? No. So I believe WGPU can handle a bunch of different type of shaders. So we might be able to just straight up grab this one, written in, what was it again? GLSL. WGSL is the shader language for WGPU. Here we go. Bump that up a little bit. Oh, by the way, if you dropped your link, Simon, is it getting, it might actually be getting moderated out. I bet you that's it. Do I have, dare I? No, we're not gonna open up Discord. Yeah. There we go. Oh, okay, sweet. It's not getting moderated out. It's getting cut off though. That's annoying. More things to do. Okay, so Chris went through a bunch of these. If you want to actually like dig into these further, we're not going to go through everything, but I want to, as far as the terminology goes, you can see here we have a little bit of familiarity here. There's new rather than a init, and there's a render, writing the shaders, and this is a vertex shader. I don't think this one's actually moving. So there's a fragment shader. And what I'm hoping for, and this is the other thing, Naga is the library that WGPU is using, also by the same group, GFX-RS. It can take a bunch of different files, GLSL, and output it as something else. And then I think the features are, you have to opt into that feature within your crate. So in the cargo.toml, you have to do this, the feature that you need to add to enable processing of those. But we have a bunch of different file not formats, like languages that we could potentially write in that then it can take and work with. So I think we could throw the GLSL at it, and theoretically it might be fine. And as far as that goes, here's a sort of a mapping, SPIR or SPIR V. I'm not quite sure how that is for Vulkan. MSL is for Metal. Vulkan is like a open source drawing library. Metal, I believe, is Mac, DX12, DX11, DX whatever is the Windows, and OpenGL is another open source rendering. I think Vulkan has been more of a thing that competes with like DirectX in that vein, DirectX / Metal. OpenGL has been more, I believe, web based. Doesn't specifically say vertex. I was hoping for like a link to is this it? Yeah, okay. So we have a bunch of types, and you can see we're starting to get into like, this is the W3 org. You know, we're starting to get into actual like specs. So it's not that we are working with another library that is doing this. It's, you know, we've gone low enough in the layers that we're actually like looking at the spec, and we need to worry about the code that the browser itself is like implementing, or whatever rendering thing we care about. So I was hoping there would be something about these directives. Okay. So a directive is a special thing that's being enabled. I was expecting a list of them though. So this like at vertex and at fragment, I believe, are directives, but I don't know where they get processed, and like, is there a list of them somewhere? So like at built in. And I don't know like what makes this shader a fragment shader. And I was kind of hoping that they would actually mention it here. Whoop. Add fragment. So we use a vertex shader to manipulate the vertices to transform a shape. So I think if you've worked with like 3JS or any of the WebGL type drawing libraries, or I guess any drawing in general, there's options for like the types of shapes-ish that you can draw. So you can draw triangles, or you can draw, I think they have a thing for like circles. Then it gets more advanced once you start getting into 3D shapes, because you have solids, you have meshes, different ways to draw those, and different ways to when you're drawing like a cylinder, so like a drink can or bottle, you're not actually describing every point. You're giving it enough input that it can take that and then redraw it, or understand how to redraw it. So like it would be a, what's the center of this thing? How tall is it? And then what's the radius, or what does that rotation look like, to actually draw the cylinder itself. So when we're talking like 2D, like a vertex to draw a triangle, we're describing it as like 3 points. And those 3 points are enough for it to draw it. And that's, if you've ever, especially if you're familiar with web, you're likely familiar with SVG versus like a PNG. So PNG is a rasterized image. The information in the file describes every dot on that image. And SVG stands for scalable vector graphics. The information in that file is actually describing the points in the triangle and where that triangle is located. And that's why the scaling works differently. If you have an SVG, the scaling or how big that thing is doesn't matter, because it's always going to say, it's based on the container, it's going to draw the same shape every time. But if you have a rasterized image, you have a specific pixel. If you make that image bigger, all that's happening is that pixel needs to be bigger. And that's when you start getting like pixelation and noise in your image, because you're seeing those pixels when they're small enough that they all just blend together. You won't notice it, but when you scale it up big enough, those pixels and those edges between each square become noticeable. So I think we're at the point where with these directives, still TBD on where those are specifically coming from, what it's doing is it's given a, like in this case, it's given a vec4. We are describing this a vertex shader, which I'm guessing there's some place we can find like specific directives or something for this. And it would be nice to understand where those are coming from, but I think we could potentially punt on that for now. Because what we want to end up looking at is some of these pipelines. So there is, we saw before the render pipeline and the compute pipeline. And here they had a blue window, and now they're drawing a vertex as well. So this render pass, I wish some of this code was like all together. I have to scroll a whole bunch to find it. Here we have a fragment, and that fragment is doing a shader. Render pipeline. So shader, I guess it's all in that single shader. So since this thing doesn't really need to move, it's just rendering it. Yeah, okay, so then we can create a second pipeline that uses the triangle's position data to create a color and then sends it to the fragment shader. Okay. And I don't think I am too worried about the other stuff. I mean, we can get into like, there's, do they have a, yeah, so like you can get into some pretty advanced shader stuff, but I think that's out of scope of what we're trying to accomplish. We just want to understand how that shader is getting into the thing and how it's actually rendering it. Because I think that's going to provide us the most valuable information to roll into the how could we potentially use WGPU and render it in a window. And we start to run into like main thread issues, and like you can only have one thing within a window potentially. But that I think is going to start to let us explore how tau and rai come together. Okay, so shader. I think we start ripping out some of this. I'm gonna just make a new shader, and for the most part, everything seems to be in this. I believe this is going to be our I'm not sure. I think we could potentially put this all in our compute, but I'm not certain. And I'm also not certain how if we switch from WGSL to GLSL, if we're going to run into issues. It looks like there is the option to do or there is a, was it GLSL? Yeah, there's a GLSL. So we could try it. Shader stage. Oh. GLSL is not fully supported and must specify a specific shader stage. Okay, so there's different shader stages. This might actually come back around to what are these directives and how do we find like a list of them? If we look at the, do they not have links linked to docs.rs? README? Oh. Really? Okay, I guess we just go to docs.rs. Docs.rs. Not doc, docs, docs.rs. Just below the part you linked. Did it scrub your link? There's vertex, fragment, and compute shaders. Okay. That sounds like what we want. I think it scrubbed your link though. Naga shader stage. Shader stage. Vertex, fragment, compute. That matches up with what you're mentioning. And I might very well have arrived at where you were linking. I'm not certain which... Is that a compute? I haven't the slightest. So like this feels like something that I can split out. But I don't know. Thank you. Nice. Discord DM. Thank you, Simon. There we go. Yeah. So shader stage attributes. Oh, look at this. Okay, so this is what I was expecting. Align, binding, built-in, group, interpolate. And we're probably not going to dive too much into these other than like just understanding like where they're coming from and how they smash into what we care about. So there's a compute, vertex, fragment, and compute shader stage. Okay, so a pipeline describes the work to be performed on the GPU. So dispatch runs a compute shader stage, and then a draw command uses the render pipeline to draw multiple stage processes. So a vertex shader stage maps input to a single vertex for a single vertex into an output for the vertex. And the fragment shader stage processes each fragment, possibly producing a fragment output. So fixed function stages consume a fragment output, updating external states such as a color or depth or stencil buffers. So I think vertex is sort of like draw everything in triangles. All the triangles come together, and then once you like have the triangles drawn, then you use the fragment shaders to handle the like how are those triangles interacting with each other, and does that interaction create change as far as the like color, depth, or I'm not certain what stencil buffers are. And then the the compute is the thing running over. Okay, so there's the compute pipeline and then the draw pipeline, and the draw has a fragment or a vertex. And this is actually starting to track with what Chris was saying last week. It's one of those things, you know, when you hear words, like you understand them and like it makes sense what somebody's saying, but it doesn't really click until you like start to get into it, at least for me. I start to get into it more and then I go, oh, this thing that I'm starting to understand and recognize, that is actually the thing that somebody said was important, or this is connected to this. So like all of those like connections start coming together. Just checking to make sure I don't have any. Okay. So the compute shader is that separate piece. The draw shader is either going to be vertex or it's going to be fragment, or potentially both. If we look at this, and we got a bunch of shader inputs here that we might need to worry about. But if we look at this, I don't actually see any directives. So TBD on which one this is. So I think we can set these aside. Oh, here, you know what? Let me drop this link in here. Was that link getting scrubbed, Simon? I'm not sure how aggressive YouTube is about stripping links, or how all of that works. So I think we have a pretty good idea of all of that. And okay, the link to W3 got removed. I guess the other link that you did was YouTube. I'm kind of surprised that they don't moderate that too. Okay, so we got a couple pipelines. I'm not certain if we need to do if we try to make a swap and we try to switch to GLSL, it's possible that we may run into issues here. We have a CLI, right? Yeah. Convert. So we can convert WGSL to GLSL vertex stage. Okay. Can we do the opposite direction? Let's go ahead and grab that. Cargo install Naga. I'm curious if we can take this. I'm not sure what render stage this is, so we'll still have to figure that out, I think. But if we go ahead and grab this, we're not modifying it anyway, so I'm gonna go ahead and just keep the copyright and everything in place. Voronoi example.glsl. Oh, that's a lot of crates. Oh, it's updating the index. So I'm assuming what we'll need to know is if we're taking a .vert. This we might need to sort of figure out. But we might not be able to go from GLSL, especially if we don't know which stage this is. But if we can figure that out, we might be able to like just produce WGSL, and then we won't need to worry too much about it. Oh, this is Created in 2013. So, yeah, I'm definitely not seeing anything as far as here, let's look at the documentation. I gotta imagine that. All right, image shaders. The main image function to generate a procedural by computing a color for each pixel. So main image and frag chord are special like functions that it handles. WebGL. Okay, so it looks like they have other apps. I actually didn't know that. Ooh, here, let's make this bigger. All of our text is really small on this website. VR shaders, interesting. So you can get shaders if you have an app key. Not something that we need to play around with, but oh, interesting. So this was made by IQ in 2013.
MacBook Air.
8 years ago. I don't know if they're actually part of the project, but I'm assuming if they have something in the footer, they probably have something to do with the project in some way. Okay. So it doesn't actually specifically say. I mean, it says for each pixel. So I'm presuming that this is compute. But honestly, I haven't the slightest idea. Okay, so there's nothing to install in Naga. Did I install the wrong thing? Is it not? It's Naga CLI. Bummer. Okay. That's fine. It's not going to take too long. Only 71 crates relative to other ones. So we can validate. I think we'll just run the Naga command and then we'll see what options it gives us. And we'll see if we can do anything with this GLSL. So Naga H help. So we need to specify a profile of translating to GLSL. But we don't want to go to GLSL. So list of files. Input and output files. So first arg is the input. The rest are output. So if we do Naga additional sources, voronoi source, voronoi example, and we do the exact same and say WGSL unknown input file extension. It is I wonder if it's not a dot, because this says .vert. I don't know actually offhand what GLSL. Okay, so it is a .glsl. GLSL. Unknown input file extension. So it might just be the fact that they can't actually convert from one to the other. You might be only able to convert into GLSL, which is a thing. So they do specifically say something dot compute. So like if we look at this tests, okay, so that's an out. Tests, in, out, errors. So you can write out. Is there a write output WGSL? Okay. So maybe it'll work. I don't know if it matters if I need to say something like that. I have no idea if it's actually a compute. Oop. Or if it is one of the others. Unknown file, input file extension. So we might just be out of luck. We might not be able to use this to convert. There is a .vert, convert to GLSL vertex stage. So that's the other thing. GLSL file extension. So some people do .vert or .frag to, I'm assuming, to help signify which to help signify which is which. So if we're assuming it's a compute, we could try a .comp, and then that might be enough for it to recognize it as a valid file type. File extension rather. Okay. Invalid version. Unknown variable. That's good. I threw that in there, so we don't actually need that in there. Now itime. Now I think itime is one of the it's one of the inputs. So I'm not sure how do we encode inputs into did we just do that? Except it closed on me. It's not in there, is it? Yeah, it is. Uniform float itime, yep. This is frustrating. Every time I click in there, it I don't know if it actually grabbed it or not. Okay. Blocks require layout. So the nice thing about this is we're going to start to get like error checking as we're writing our shaders, and other ways that I've seen people write shaders. I don't know about Shader Toy. I haven't actually watched anybody write something on Shader Toy, just have seen the end result. But other shaders that I've seen people write don't have any error checking. So I think it would be kind of nice to see what it's like to write shaders using Naga and have that validation in there. I suspect that would be valuable. Okay, so I don't know what a blocks require layout. I don't know how to describe that right now. I presume this is like some level of input here. So what I'm gonna do is I'm gonna grab this, and we will comment this one out just so we have it. And we're gonna say 10 and just see what happens. Kind of deal with one specific thing at a time. I mean, if it doesn't move around, but we can get it to load, we can always make it move around afterwards. Okay, unknown variable, I resolution. I don't know exactly what we're doing here. Well, I mean, I get what we're doing, but like, do we need it is maybe the better thing. I think maybe we just take that out for right now and see what happens. Missing entry point. Okay. Void main. Back out frag color in vec2 frag coordinate. Frag coordinate is guess it doesn't specifically say. I'm presuming we got an out vec4 frag color. We also have an in vec2 frag coordinate. Can we do an in I time? I'd assume so. What does I resolution look like? I resolution is a vec3. Can I do another one of these? In vec3 I resolution. Still missing entry point. GLSL missing entry point. And it must be called main. So we need to declare a main function. So if I just say fn main, expected end of file found identifier function. I mean, I had a main there before. Maybe it's the void. Expected end of file find identifier main. GLSL entry. I really just need like an example of a W or of a GLSL named entry point. So there should be a void main. And this one's got subroutines. So we should be able to do void main. If I spell void right. And then here we have a vec 3 and a vec 2. Those functions end up getting used here. Where's hash 2? So hash 2 is used in voronoi. Missing entry point. Interesting. GLSL missing entry point. We'll try that again. Okay, so this error mostly happens when you pass a vertex shader into the fragment shader stage. So if we have a main, does that... Let's go back to this yeah, go to site. Let's grab this link again that Simon shared. Oh, that's not it. Let's try it. Did not copy. Okay. Entry point. So this is an example. And this is all on WGSL. So I'd imagine that there's probably the same for GLSL. W3. So this is the WebGL spec, which I believe is what maps to GLSL. The entry point? Legacy entry points. So okay, so we have a bunch of entry points. It might not be worth actually trying to get this to work. I'm going to suspect that what we can do is say we have a draw. The draw is this is computing the actual triangle, and then we have a compute. The compute handles the location. If we say take this, we are... I don't think we're doing anything that's too advanced here. I'm tempted to say let's try to convert this just by hand to WGSL. And this is the piece that I'm not 100% sure on. But I think this is all something that we could put in a compute. So compute figures out the location, draw figures out the what that shape looks like. So if we take a look at what is it going to be easier to read in here? It is calculating a voronoi, and then it's figuring out the distance. And it's returning a vec3. So if it returns a vec3, that is telling me that we are getting a vertex and then a fragment. So this, I think, could be the thing that we drop into our draw. And then this, I believe, is our compute. TBD. Let's see if we can get it going. What time we got? Ooh, we're almost coming on 2 hours here. We're gonna give this a shot, I think. We're gonna give it a shot. So if we take out all of the compute, right back, particles, destination, and then particle. Particle is a struct, which is a position and a velocity. Do we end up using that anywhere that we would care about? So we have a compute. And then it gets combined in all this stuff. So I think this is going to be the part that's definitely a little bit involved here. If we go ahead and let's go ahead and just copy both of these. And we are going to swap them out. And we'll say compute and draw. And if I can, wow, I spelled it wrong both times. And we should be able to swap these. And it should work. So if we give this a run again, it should work, because all we've done is change the file names, but just to be certain. Okay. Now if we go into our draw, this is doing a vertex and then a fragment. If we take our example here, this whole thing is returning a vec3. So if we would say, let's use this instead. And that's going to be returning a vec. So this actually returns a vec4. So we might need to like tweak it. That's fine. So if I don't care about the actual velocity and I drop this in here, we're returning a vec3 here. I am going to comment this out. I'm going to then return. Let's do this. what we're going to do is we're going to do this. No idea if this is actually going to work as intended. Let's see what happens. So we've just swapped out the draw. So this should be the thing that's determining the triangles. So I think it should still compile. It's going to look very different though, I'm presuming, if it even works. Okay, so we do have errors, which is fine. Expected equals for assignment. So there is what looks to be a little bit of conversion that we do need to do. So it looks like what we need to do actually here is say let this equals this. And we got to describe what kind of vec2. Oh, vec2 f32. And before we get into it too much, let's see. So we're saying an N and then an F on line 7 and 8. So if we fixed those, and now we rerun, those should go away if I've done it right. Okay. Unexpected for variable declaration. So when we're defining our variables, okay, so this is actually calling that a vec2. Let's go ahead and open up the compute. So there's definitely a lot more going on in the compute, and I can use that as a decent example. So when we establish, okay. This, I believe, is actually the syntax that we want. So we're setting that variable n, which is a vec2, to the value floor, based on whatever that method returns, which should be the type that we've described. Okay. So now can we just freely assign this variable? Seems like we potentially need to do something like this. And we'll say let mg and let mr. I'm guessing that float md is not something that we need either. Let md float. I don't know if that's going to be valid or not, but I definitely know that these are not going to be. Let. Now it's redefining these. There is also the, like, this looks like it should be commented out potentially. let's give this a shot. I think this was all the variable assignment errors. It does say something about variable assignment there, but yep, okay. Invalid character found. I suspect we can remove that. Let's just comment it out for right now. And here and here. And then we need to figure out how to do, I guess we could probably say do let int It'd be nice to have this rebuild every time I save. I thought we had that working, but perhaps not. Okay. Unexpected that for loop. So let's go ahead and look at. So they have a loop. That is specifically a for loop. This code here does not have a for loop. It just has a loop and it breaks out of it, which is fine. WGSL for loop. Okay, so it doesn't have this. What specifically was the error? What didn't it like? Unexpected squiggly bracket in for loop. It's like a nested loop here. We might need to do this. I'm guessing it's this is what it's expecting. Then we have another one there. And do we have like formatting in this? Ooh. Format document. Ah, okay. No formatter installed. It's fine. So just based off a syntax highlighting here, I'm assuming that this is actually the syntax that we want for this. I gotta say the value of IDEs is continuing to grow on me, because the fact that I'm like reading no documentation and sort of just relying on my syntax highlighting and resolving these errors. I mean, some of the, like, I wouldn't see this error just through the syntax highlighting, but between this and the syntax highlighting, just the fact that I can actually get somewhere around this is pretty nifty. So I missed one. This should be a float. And then we've got a expected squiggly bracket here. Got a for loop. We have that. Expected squiggly bracket for if statement. Oh, if. Got it. I'm assuming that's what it's looking for. Unresolved identifier X. Okay. Getting somewhere. I think we've resolved most of the issues, and now X. Where does X come from? So we've got a bunch of position stuff here. Is X an input? So all of the inputs start with an I. That's a good way to kind of handle that. I'm gonna need this, but I don't know if that's actually where I would put that. So I'm very certain that we're gonna have to come back to that and deal with it. Okay, so it's an input in vec2 x. So our function is doing fragment location, return a vec4. That might be fine. Positionally, we are doing a compute, which has a main, and we are giving it particle, a position and a velocity. I bet you it's in here. So compute pass. What I'm looking for is we are expecting in our existing draw these directives for location, and I'm guessing it is referring to the location of like positional args. So the first arg is going to be particle position. So what we should be able to do is say something like we might want to like move these around, but our x is actually going to be a vec2. So like we're expecting something of that sort, where I anticipate now, having made that change, it's going to throw an error because we need to fill that in. Kind of interesting that I'm not getting. Oh, okay. Unresolved type float. WGSL float. Floating point types. So how do I specify it? The F for 32 is a 32-bit. Oh. Are we using F30 or F? Yeah. So what's the difference? Should we just try F32? Scientific, right? Come on. Unresolved type int. So now we need an integer type. The U32 type is a set of 32 unsigned integers. I32 type, set of 32 bits signed integers. I'm not certain what we need, but I'm going to go with I32. Because we might need signing? I'm not sure. There's a -1. So the difference between signed and unsigned, signed would be able to represent negative numbers. So it's a U32 on like either side. So U32 in the negative and U32 in the positive. So it you do kind of want to pay attention to the data type, because depending on which one you pick, you could potentially get like double the amount of required memory for that. But it seems like we do have a negative, so I'm going to go with assigned. So it has the sign. And then, what else do we got? Cannot modify a let. So on the for loop, it is saying, let this be this, and if this, and then after it's done, increment. Let's look at the for loop syntax again. WGSL for loop. So we can't, I don't think we can increment. We might be able to do that syntax though. So if we say plus equals so if we replace all the plus plus with that, let's see what happens. That is more Rust syntax, and I think they do actually mention Rust. So we'll see. Yeah, cannot assign to let J. So, and they do have a mention here that it's, I'm guessing it's been merged in. They're saying that it's not supported yet, but that was back in 2022. So fingers crossed. Let and var. So it's saying that we can't like reassign to the so we might actually have to change that to var. But let's recompile and we'll change it when it actually throws an error and tells us to. So we're not trying to change too much at a time. Okay. So it is, we're converting this thing to a float, I think is the intention here, but I don't know that we actually need that. Let's take out our float calls here. I'm assuming that what it's going to do is do the conversion for us. That seems to be sort of the case for newer languages and how it's handled. Okay, so we can't, all right. So this is saying we cannot initialize let of type vec f32 with a value of vec to i32. So WGSL can convert i32 to f32. I mean, it keeps saying Rust. It's not really Rust. Oh, okay. You need to use int to float. Okay. Well, there we go. Just want the. So let's actually undo. int to float. And those are those directives again. Since we have this handy still, do we see an int to float here? Int to float. So possible this might not work, but I'm not sure where that value would be coming from. Yeah, okay. Oh, unexpected. So how do we create a vec32? We're actually gonna run into this hash2 pretty soon here as well. So WGSL create vec2. This might be very handy. Vec2. The cursor thing is interesting. All right, so okay, we just did those conversions, so that's helpful. We did specifically say I32, so we got that correct. We want to uniform buffer function declarations. So we want to create a vec2 here. Okay. Apparently it is one of the goals was to make it closer to TypeScript. Interesting. Okay, so what they're saying is, in reality, what we want is this. And then I'm guessing we need the same here. We also have this hash. And we have this floor and fraction. I kind of wonder if those aren't actually working either. And this hash2. I wonder if we can grab them. I don't know if we can just say function hash2, take at location 0 p as a vec2. Let's give it a shot. I think this is actually going to be really handy. Thank you, Damien. I'll go ahead and drop a link in the chat here. Expected closing paren for function call. So, so in this case, like a function has an input. Oh, okay. Function declarations. We actually did get that wrong, it looks like. So we need to say just this. I don't think that location seemed to make a difference. And then we say to an F32 or vec of F32. And I don't really like the syntax this way. I prefer the closing squiggly bracket right there rather than on the next line. And this does have some vec2 stuff in here too, so we're gonna have to, once we figure out this, guess we can just do it now. Sure. So, yeah, we need to figure out how to convert float. I love this. The hopes of not having to rewrite GLSL shaders stop here. Yeah. You can only pass vectors to construct the matrix. Okay. Okay, so we... Oh, okay. So there's var and let. And if you want it to be immutable, you do let. No preprocessor, okay. F32 everywhere. Branching. Oh, I see. Okay, so what they're doing here is they're writing a function called toLinear that takes multiple types of data types, and based on the data type determines what it's returning. But we can't do that here. Fair. Okay. So we still need to figure out how to convert I32. I kind of wonder if we just say this, if it's going to handle the conversion for us. Which was the guess before. But another post mentioned that there was that directive, but maybe that was context dependent. Like, it's not actually in the spec, so it might just be in something specific. Okay. No matching constructor for vec2 F32 to this. That makes sense. We have candidate constructors. So we can say we want to take we have a vec2. Oh, wow, is this big enough? So we have candidate constructors. What it's saying is that we could do a vec2 with T, but I don't want that. I want a vec2 I wanted to return F32. So like we might be able to do this. This seems to be wait. Is this the examples and this is what you end up getting? That could very well be. I'm not certain. I am not certain. Let's try this though. Which is awful verbose, but if that's what we need to do, that's what we need to do. Let's see what that gives us. Yep, okay. So that definitely wasn't what they were trying to say. I think it was showing us based on which one we picked would I believe give us one output versus the other. So they're saying if we go with this, so that would give us a U. We want it to be an F32 though. All right, let's see if we can Google it and say WGSL vec2 of F32, vec2 of I32 to F32. Ooh. Okay, so like this is a function. I mean, do we need to write a little function to do this? That's sort of annoying. I mean, this is specifically in Rust, I think. Takes. Do they have takes somewhere? I mean, it says in Rust on the title. Okay, so that's in GLSL. Using vec4 F32 instead of matrix 2x2 F32 fixed issue. Interesting. All right, let's try no matching constructor. Because I want something that is describing how to fix I32 to F32. So if somebody else has that same issue, theoretically I should get so this is all talking about like specifically within like the spec, I'm guessing. To do specifically, well, convert I32 to F32. So this one says vec2. So this function is returning an F32 and it's taking a vec of I32. I don't know what this 1.f means. So like if we go in here and we say I dot that seems awkward. Okay, invalid member. Yeah, okay. How to convert an F64? Okay, well maybe, but this is also in Rust. Yeah, we want it for WGSL. Between types. One is converted to an F32. So if we do 1.0f, okay, unsuffixed integer literal can convert. Oh my goodness. So these are actual like values. So if we have if we're specifically like inputting them, we could say like a 1U and it would figure it out. But if that value is a variable, how do we deal with that? Integer type, floating point. I mean, it could very well be that I don't. I guess I kind of do. If they're using an integer before, then I should continue using it now. Floats might get weird on it. F32, U32. Oh, they do have an I++. I'm actually going to switch these. I think those were let before, so it wouldn't let us do that, I'm guessing. Let's try it real quick just to make sure that we didn't regress a little bit here. I think we'll go for a little bit longer here. Yeah, okay, cool, sweet. If we can figure this out, I think this is probably where we're gonna stop, and then we'll... The shader stuff is taking a little bit longer than I was expecting. I mean, we are sort of like learning a whole new language here. So not surprising, I guess. But I was hoping to take a couple of examples and smush it together and have something work. But we're operating at like a low enough level that like, especially with having to convert and whatnot, we're basically end up. I mean, if this was written in WGSL, then we might be fine. But unfortunately, not the case. var f30 or var I32 to f32. So it can go from an abstract int to abstract for multiplication. So it implicitly converts. So we're specifically saying in this case that we want a vec2 of f32. Or that it is. So if I say, no, actually this is I32, but like let it be an f32, is that gonna work? It seems like that conversion, yeah. So, I mean, maybe we just roll with this being an I32. And let's see what happens. It seems that much of this documentation is implying that it will handle the conversion if it's able to. Okay. So this is actually going to be an F32 because an F32 plus an I32 I think is going to become an F32. Okay, stop looking at me. Ugh, again with this cat. Come on up. Come on up. Can you see it? No. Meh. Don't know why you've been shy lately. Okay, so no matching overload for operator. Plus. Got it. So we can't add those together because they are different types now. So MG is strictly used there. So I could actually say, I could call this an I32. And fingers crossed. So we don't need them to be .0 because that implies the floating point, and I think that's the error that it's noting. Okay. No. Hash. So hash is taking N and G. So hash is definitely expecting vec2 of f32. And we're doing an n, which is a vec2 of f32, and a g, which is a vec2 of I32. It's kind of annoying to have to like rewrite all of this. I suppose we could say let's take an n and a g. And we're gonna say let p equals vec32 equals vec f32 and n plus g, and now we say n and g, and in this case g is going to be I32, and let it do like the type conversion in that hash. So then we say here n and g, and then here we say n and g. Oh boy. Okay. We're into the hash. We might need to split this up. This is kind of not great to read. So sine of a what is that even? Vec2 let thing vec2 f32 equals this. I don't know if that's actually gonna work, but because this is still, we're doing like a vec2 within a vec2 kind of thing here. Expected, semicolon. Seems like I actually didn't need a semicolon on the other one, but maybe I just missed that error message. Okay. N plus G. I mean, we could potentially just say, hey, do your thing. Let's see what happens. Bummer. All right, well, I think we still have a little bit more to get through. It's sort of unfortunate that we're having to like do this whole conversion. We have sort of this piece here. We're making a good amount of progress, I feel like. Then what's left is going to be this piece, which is I believe, the compute part of it. So we'll get the vertex and I don't know, maybe this fragment. I'm not sure if we need this fragment or not, but we should be able to get a vertex done, and then the compute we'll still need to do. I was hoping we would get this done today, but it's seeming like we're not going to. Well, I mean, obviously we're not going to because we're into the stream here. So I think we'll pick it up next week. I think whatever we get to next week, we'll probably just call it. I think we're at the point where we're like 80-90% done, and getting this swapped in and implemented isn't going to actually adjust or help our understanding of how these things fit together, and is going to start to be outside of the scope of like, is this going to be beneficial to dig into and learn more about, as far as pushing forward our understanding of how like pieces fit together and whatnot. I still do want to have that replaced, so like I'm not abandoning that goal, but I might just do that off stream. We'll see where we get to next week. So next week, Tuesday. Thanks for stopping by, everybody. Same time, same place. I'll see you next time. Bye.